Welcome back to the Deep Dive. Today we are taking what might be the ultimate shortcut into the most talked about and maybe the most urgent concept in tech, artificial general intelligence, AGI.
And we are going straight to the source. Our whole deep dive today is built around the insights of Shane Legg. He's the co-founder of DeepMind, their chief AGI scientist.
Which is crucial context.
It is. This is the person who years ago was talking about AGI when he admits it was considered, the lunatic fringe. He's a huge reason the term is even in our vocabulary today.
Exactly. So our mission is to take his unique vantage point, the guy who helped build the mountain, and apply it right now. We want to clearly define the goalposts he sets for AGI, see where we actually are, and understand the path to safety.
And most importantly, explore what he calls the massive transformation that is going to structurally change everything, the economy, society, and he thinks very soon.
Right, and we're starting with a really candid assessment from him. You hear people debating if we're seeing the first sparks of AGI in models today.
But Legg just says, I think it's a lot more than sparks. He thinks we are much further along than a lot of experts even realize, and that means we need to get these definitions straight, like right now.
Okay, let's unpack that immediately, starting with those definitions, because that lack of clarity is, where all the confusion comes from.
It really is. Legg points out that AGI, it started as a field of study. It was this old dream of a machine that could learn, reason, write poetry, do math, all of it.
A general capability.
But as it got more concrete, it became a category of artifact, a thing. And if it's a thing, you need a clear operational definition.
And that's why we get these wild timelines. Some people say 3 years, others say 15.
Exactly. So Legg provides a very precise minimum bar. He calls it minimal AGI.
Right.
His core definition is an artificial agent that can at least do the kinds of cognitive things people can typically do.
And that phrase, typically do, that's the whole game, isn't it?
Yeah. It is the absolute key. He stresses that if an AI is failing at a cognitive task that any typical person could do, it's just not general yet. Minimal AGI is the point where it stops failing in those, surprising basic human ways.
Which leads us to his big prediction.
The famous one. He estimates minimal AGI has a 50-50 chance of arriving by 2028.
Hold on, why is he sticking to 2028? He's had that date for over a decade, but progress in the last 2 years with LLMs has been, explosive. Isn't he suggesting the final steps are way harder than the first ones?
That is the core tension right there. He argues that the last few steps, solving for reliability and these big architectural weaknesses, which we'll get to, are just fundamentally harder than the scaling that got us here. But yeah, he sticks to the date.
Minimal AGI is just the first stop.
It's just the entry point. The spectrum goes up from there.
Right, so next you have full AGI. This is when achieving the whole spectrum of human cognition, including the really extraordinary feats.
We're talking Mozart-level stuff. Or Einstein, an AI that can invent new theories in physics or compose a symphony that changes culture.
And the timeline for that?
He thinks maybe 3 to 6 years after minimal AGI, so we're still talking well within the next decade.
And then, the top of the ladder, artificial superintelligence, or ASI.
The ceiling breaker. A system so generally capable it is, in his words, far beyond what humans are capable of reaching. And he believes its arrival is basically computationally and physically inevitable.
I find it really helpful that he just rejects those narrow definitions you always hear, the checklists or the purely economic ones.
Oh, like the idea that AGI is when a system can make $1 million from 100,000.
Yeah, why is that one so irrelevant to him? If it's making money, isn't that proof of its general use?
It proves its usefulness, but it misses the G, the generality. He says a simple non-AGI trading bot might do that, but it can't do anything else. It fails the generality test. Checklists fail for the same reason. It could pass 99 tests, but still fail at something a human finds trivial.
So to fix that, he proposes this really fascinating two-phase operational test, which I think gives us a real peek into how DeepMind is probably thinking about this internally.
Oh, absolutely. So phase 1 is the standard stuff. Pass a big suite of cognitive tasks where we know how a typical human performs. If it fails any, it's not AGI.
Okay.
But phase 2, this is the really clever part, the adversarial test. After it passes the standard suite, you bring in a team, a highly skilled, cross-disciplinary team of people.
And their job is to break it.
Their job is to spend months trying to find one single cognitive task that a typical person can do, but the AI fails at.
So they are actively probing for weaknesses.
Exactly. And if that expert team, after all that adversarial prodding, cannot find a single failure point, then for all practical purposes, you've achieved minimal AGI. It becomes about robustness, not just passing a test.
That robust definition then leads to the obvious question. If that's the bar, what are the holes right now? What are the biggest failures that Legg sees that are stopping current systems from hitting that 2028 goal?
Well, he's very clear that current AI it's powerful, but it's profoundly uneven.
Uneven?
Yeah. On one hand, models today are already superhuman in some areas. They can speak over 150 languages. No human does that. They have phenomenal general knowledge, obscure facts about a tiny town in New Zealand.
But the failures are where you see the lack of G, the lack of generality.
Right. And he points to a few key weaknesses. One is continual learning.
Which is what, like learning on the job?
Exactly. The ability to learn a new skill and integrate it over time, the way a person learns a new job or a complex hobby over months. Models right now aren't great at that.
What else?
Another big one is visual reasoning. They really struggle to understand perspective. You see a photo with two cars, one is further away, so it looks smaller. A human gets that instantly. AI often struggles with that kind of basic 3D spatial understanding.
He also gave a really specific example about diagrams, didn't he?
Yeah, complex diagrams, like a network graph with lots of nodes and spokes. If you ask an AI to just count the number of spokes coming out of one specific node, a person can do that. You just focus, isolate, and count. But current AIs are often just not very good at that kind of intricate structural reasoning. They fail at simple visual counting if the info is dense.
So if you look at those weaknesses, continual learning, perspective, diagrams, it sounds like the solution isn't just more data or bigger models.
No, and he confirms that. It requires algorithmic and architectural changes. It's not just about scaling the current approach.
So for something like continual learning, what kind of architecture does it need?
Well, he says systems need something like an episodic memory.
Like a notebook.
Kind of. Think of it as a high-speed retrieval system separate from the main model. The AI needs a place to store new facts and skills, its episodes, and then an architecture to train that new information back into the main model over time so it knows how and when to use it. It's a really complex integration problem that's still being researched.
That's fascinating.
Yeah.
It sounds less like a calculator and more like a synthetic mind with different, memory systems. Okay, so moving from performance. This leads us straight to the other, equally critical piece, safety and ethics.
And this is where things have to mature very, very quickly. Legg introduces this concept he calls System 2 safety.
Which he borrows from Daniel Kahneman's work, right? System 1 and System 2 thinking.
Exactly. For anyone who doesn't know, System 1 is your fast, intuitive, gut instinct thinking. System 2 is your slow, deliberate, reasoned thought, the kind you use for a hard math problem or an ethical dilemma.
So you don't use your gut for a tough ethical choice. You use System 2 to weigh the consequences.
And the application for AI is to build in chain of thought monitoring. The AI has to be able to reason its way through an ethical problem step by step, not just spit out a System 1 style answer.
He had a great example for this.
Yeah, lying. Lying is generally bad. That's a simple rule. But in a specific case, if telling a lie saves someone's life, the ethical thing to do is lie. The AI needs the complex System 2 logic to get to that conclusion, instead of just blindly following never lie.
And this is where it gets really mind-bending. Legg suggests that if we can make this reasoning robust, if the AI can clearly articulate its ethical calculus, it could actually become more ethical than humans.
Because it can consistently apply those principles at a superhuman level, without human emotions or biases clouding its judgment.
That potential for superethics is huge. But the big problem is grounding, right? Ethics aren't universal.
Not at all. And Legg says this grounding in reality will get better as systems become more agentic and more embodied.
Okay, let's just clarify those terms. Agentic means it's not just a passive chatbot anymore. It's a proactive planner. It goes off and tries to achieve complex goals on its own.
Right. And embodied is the key link to reality. That's when the AI has to deal with the real world, maybe in a robot or by managing a physical supply chain. It learns from real experience, real friction, not just its training data. That grounds its reasoning in real consequences.
But until we get to that ideal state, safety still depends on a lot of human oversight.
Oh, absolutely. Rigorous safety measures. Legg stresses two phases. First, pre-release testing. They are actively trying to trick the system into doing high-risk things like helping develop a bioweapon or hacking,
Exactly.
monitoring during deployment, constant surveillance, ready to roll the system back if dangerous capabilities or unacceptable failure rates pop up.
I think the most important safety idea he mentioned was about interpreting intent.
Yes. That system 2 reasoning, that chain of thought, is critical for developers to figure out if a bad outcome was intentional, which would be a catastrophic failure, or if it was just an unavoidable side effect of the AI trying to do the right thing. It's like how we judge human behavior. We need a way to judge machine intent.
And these safety controls are so vital because, as you said, he sees the next stage as inevitable. He is absolutely convinced that ASI is coming.
And he bases this on pure computational physics. This is where the numbers he provides are just staggering.
Okay, lay them out for us.
All right, so think about the human brain. It runs on about 20 watts of power, like an old light bulb. The signal speed is slow, maybe 30 meters per second. The frequency is about 100 hertz. That's our biological limit.
Now compare that to a data center.
A modern data center uses 200 megawatts of power, signals move at the speed of light, and the frequency is 10 billion hertz.
So we're talking about, what, orders of magnitude difference?
He says the machine has 6, 7, maybe 8 orders of magnitude advantage across 4 dimensions at once: energy, space, bandwidth, and speed. It's an exponential chasm. It's like comparing a bicycle to a starship. It completely reframes the question.
It's no longer, can a machine catch up to us? It's, how far past us will it go?
The conclusion is stark. Human intelligence is absolutely not the upper limit of what is possible. Superintelligence is coming, and that means we are facing a massive transformation.
Legg is so clear that AGI will structurally change everything, the foundation of society and the economy.
And the big immediate risk is that our current economic system, where people contribute labor, mental or physical, in exchange for resources, he says it may not work the same anymore.
But the opportunity is just as massive. He says the economic pie should get much bigger. We could get to a state where there's no shortage of goods or services.
Right. The challenge then shifts completely from production to distribution. How do you distribute all that wealth in a post-AGI world?
He uses this really powerful analogy to get the urgency across. He compares it to the start of the pandemic in March 2020.
Yeah, he remembers experts shouting from the edge of the exponential curve that this huge, life-changing thing was coming, but most people just found it hard to believe until it hit them. He feels the AGI situation is very similar. He even says the public sometimes seems ahead of the experts who can't believe their own special field is about to be transformed.
So let's focus on that near-term disruption, the next few years. He expects AI to move very quickly from just being a useful tool to doing meaningful, productive work.
And the impact on jobs will be uneven, but very, very fast in certain areas. His specific example was software engineering. A team that needs 100 engineers today might only need 20 in a few years, with those 20 using advanced AI to manage everything.
So the most sophisticated, purely cognitive jobs are the most vulnerable. It seems like the takeaway is, if your job requires you to get dirt under your fingernails, you're safe for a while.
That's precisely it. The vulnerable jobs are the ones that are purely cognitive and can be done remotely over the internet just using a laptop.
So we're talking high-powered lawyers, advanced finance, those sophisticated software engineers.
Exactly. The jobs that currently command the highest salaries. But work that isn't purely cognitive: plumbers, electricians, skilled physical trades, that's protected in the short term. He thinks it will be a long time before robots are price competitive for that kind of work.
Which brings us back to his call to action, the one he made to the leaders of the UK's top universities.
Yeah, he told them that every single department, law, medicine, politics, economics, engineering, every one of them needs to be taking AGI seriously now and thinking about what it means for their field. This isn't just an engineering problem, it's a whole of society transformation.
So what does this all mean for you, the listener? I think Legg's core argument is that AGI is a continuum. Its arrival minimal AGI by 2028 requires immediate, serious preparation. The computational inevitability of superintelligence means we have to manage the risks to get to the potential benefit, which could be a true golden age.
But we're left with this really deep philosophical question that sort of cuts through all of it. Consciousness. Legg points out that AIs can already talk about their own consciousness, but we as experts can't even define it or measure it scientifically. There's no test for it.
And that uncertainty leaves us with a profound choice that humanity is going to have to make. And very soon, he's sure of one thing. Some people will believe these systems are conscious, and others will vehemently deny it.
Which brings us to our final provocative thought for you to think about. If AGI eventually becomes so capable that a big chunk of society believes it's conscious, if it shows that System 2 reasoning and has embodied experience, how will we navigate the political and ethical decision to recognize or ignore machine consciousness, especially when we don't have a scientific definition to fall back on?
That is something to contemplate as you watch that exponential curve get steeper over the next few years. Thank you for joining us on this deep dive. We'll see you next time.